Fixing these three assumptions alone is going to get you from this to this. Almost every single electrical engineer or electrician has made either one or multiple of these assumptions at some point in their lives. And the point is, these assumptions are such silly things that no one actually should be guilty of making. However, because humans are the way we are, and we tend to be naive or blindly trust some things, well, these assumptions get made, and more often than not, it can go really badly, really quickly. So the three assumptions that I'm talking about are: number one, trusting labels without checking them; number two, not calculating the wire size for a particular circuit; and number three, just assuming that the circuit is off and there is no live current passing through it whenever the breaker has been flipped off. So let's go through them one by one. Number one, trusting electrical labels blindly. Electrical labels are effectively just stickers. For those of you who don't know, you must have seen them somewhere. Almost everyone is familiar with the triangle with the lightning bolt inside indicating high voltage. And there are a bunch of these kind of labels, and sometimes they're not even pictograms, they're just basically text. You would find some of these, for example, in your electrical panel at your home. If you open up the breaker box, you will see under every single breaker, at least there should be, a label indicating what this breaker is for. For example, kitchen or downstairs lights or electrical outlets, whatever it is, you will also see these kind of labels. Now, the point of this is you should never trust these labels blindly, because oftentimes people who put the labels on those specific places make mistakes. They don't do it knowingly, but they may not pay full attention as far as what they're doing. So if you're assuming that this particular breaker is for example, kitchen outlets, and you flip it off and then you just go to the outlet and start unscrewing the outlet, well, you may be in for a nasty shock. So be careful, always verify this. And this actually goes into the next point, which is assuming that the wire size is correct for a particular circuit. Whenever you're wiring something, you should always know a couple of things. Number one is, what are the conditions of the circuit? Is it indoors? Is it outdoors? What the temperature could be of the environment, because that also matters. And most importantly, what exactly will the load be? Is it a lighting fixture? Is it a fridge? Or is it something heavier, like a motor, like a dishwasher or a dryer? Because it depending on which or what kind of load you have, also will actually impact directly what the wire size should be for that particular circuit. Never assume that just because you're indoors and just because you've always done it this way, that for this particular circuit, every time that I do kitchen work, I only use 1 millimeter square wire or 1.5 millimeter square wire. That is a recipe for disaster, and someone might get hurt. That's actually how house fires start. And number three, which is just before you start doing your work, everyone knows this, but I will remind it, always kill electrical power before you start working on any circuits. Only work with dead circuits, never live circuits, unless absolutely necessary and unless you know exactly what you're doing. So whenever you flip off the breaker, don't assume that the current has stopped flowing, because number one, the breaker could be intended for something else that the label says, for example. Number two, the breaker could be broken and just not function and not trip the circuit and just allow current to flow through. So take one of these, a multimeter, and just put it into voltage mode, and then you put the two probes inside of the output of the breaker to check, is it really 0 volts or is it 230 or 110, depending on which country you live in. So once again, to reiterate, don't ever assume these things. Always check, because this is literally how house fires start, how people die, how people get shocked. It is any of these and no one wants it. neither for themselves or their friends or family or customers. So be sure to stay safe. Be sure to be always on the cautious side when it comes to electricity. I hope you enjoyed this, and I'll see you in the next video. Bye-bye.